Alright, ladies and gentlemen, this is 018 Notes on Simplifying Radicals. Your objectives: you'll be able to simplify a radical expression. So, let's break some of these down here. So, problem number 1, we have radical 50. Our goal is to simplify this radical and break it down. So now 50 could be made up of multiple numbers. We could do 5 times 10, we could do 2 times 25. We know there's lots of factors. Right now, I just want you to think of 2 factors that could break down 50. Now, the 2 that come to my mind first are 5 times 10. So when I break it down and do my little factor tree, I take my 50, I break it down to 5 and 10. Now 5 is a prime number, so I would circle it. Now 10 is composite, meaning it can be broken down even further. So I take my 10 breaks down to 5 and 2. So my other primes are 5 and 2. Our goal when simplifying these radicals is to break it all down so we have a list of prime numbers. 5 times 2. These 3 prime numbers multiplied together will get us that 50. It will get us our original, what we were originally trying to break down. Now 10, we don't have to worry about 10 anymore because we broke that down to 5 and 2. And 50, we broke that down between 5 and 10. So we'll cross those out. So we have 5, 5, and 2. Now, with working with square root, there's an imaginary 2 on a square root. That means you need 2 of the same kind in order to take it outside that radical. So we have 2 5s, so a 5. So it's 2 of a kind, so you need 2 in order for it to be on the outside of the radical. Now 2, it doesn't have a partner, it doesn't have a second 2 in there. So we have to leave the 2 in on the inside. So we have 5 radical 2. And that's why for number 1 our answer is D. Let's do a couple more. Here's problem number 2. We have the square root of 27. We got to simplify this radical. That square root has an imaginary 2. That means you need 2 of a kind in order to take numbers outside the radical. So I think of 27 and I break things down. I know 1 times 27 gets us 27. I know 3 times 9 gets us 27. So I write 3 and 9. Now 3 is a prime number, so I circle that 3. 9, however, is composite. That means I could break it down further. So 9 is made up of 3 times 3. So that's how I get my other prime numbers. So all the ones I circled are the prime numbers, and our composite ones, we broke them down. So 3 times 3 times 3 is 27. So that's how we know these are the prime numbers being multiplied together. That will get us that number, our original number in our problem of 27. So now we need 2 of a kind. So this 3 and this 3 will make up the 3 for the outside. Now this 3, since it doesn't have an additional partner, we leave it on the inside. So it'll be 3 radical 3. So number 2 is A. Now square root of 20. We know 1 times 20. We also know 2 times 10. So I write 2 and 10. 2 is a prime number, so I circle it. 10 is composite, so I got to break 10 down. 10 is 2 times 5. So you have a 2 and a 5. I'm going to cross out those composite numbers that we broke down. 2 times 5 gets us 20. Now this is, since there's no number there, there's an imaginary 2. That means we need 2 of a kind, so these 2, since they're the same number, we can write it on the outside. Now 5, it doesn't have a second 5, so we can't pull out that 5. It has to stay on the inside. So we have 2 radical 5, which is C. Look at number 4. We have the square root, aka the imaginary 2, of 216. So now it's a bigger number, we still take the same strategy. So 216, since it's an even number, I like to divide it by 2. If it's an odd number, I like dividing it by 3 to see if that works out. And I can just test a few numbers, the first couple prime numbers, to see which ones are divisible and comes out to nice, pretty integers. So now 216, it's an even number, so it's divisible by 2. Let's make this a little bit easier on your screen. Put it right over here and make it bigger. So we have 216. We break that down and we get 2 and 108. So 2 is a prime number. So I circled it. Now 108, that is a composite number. We could break that down further. 108 is also divisible by 2. So I got 2 and 54. 2 is another prime number. So I circle it. 54 is composite. We know 54 divided by 2 gets us 27. 27 is composite. 9 times 3. Nine is composite of 3 and 3. We got red, we cross out all our composite numbers. And now all these red circled numbers are the prime numbers that if you multiply all these prime numbers together, you're going to get 216. 2 times 2 times 3 times 3 times 3 times 2 gets us 216. Now we need 2 of a kind in order to bring it on the outside of the radical. So here's my radical. This 2 and this 2 can be represented by that 2 out on the outside. This 3 and this 3 is also on the outside. And we have a 3 and a 2. Well, 3 and 2, they're not the same number. So we have to write both of them on the inside. So 3 and 2. Now you could see that we have multiple numbers on the outside and multiple numbers on the inside. When we have multiple numbers on the outside, we multiply those numbers back together. So 3 times 2 gets us 6. Now when we also have multiple numbers on the inside, we multiply those two numbers together. So the outside stays on the outside, the inside stays on the inside. 3 times 2 will get us 6 on the inside. So we have 6 radical 6. So 4 is D. Here's number 5, 343. Now 343, that's a little bit tougher. 343 is not divisible by 2, and it's not divisible by 3. So we have to try some other numbers. We do 343 divided by 4, that doesn't come out to a pretty integer. Divided by 5, it doesn't come out to a pretty integer. Divided by 6, it doesn't come out to a pretty integer. But when we divide it by 7, 343 divided by 7, we get 49. So 7 and 49, they're both integers, so we'll write those down. 7 we know is a prime, 49 is composite, meaning 49 can consist of 7 times 7. So we got a 7 there, and a 7 there. 49 is composite, so we delete it, and 343 is composite, so we delete it. So 7 times 7 times 7 gets us 343. Now we need 2 of a kind again, meaning 2 of the same type. So we have 7 and 7. So I could say this 7 here and this 7 here. Make up that 7 on the outside, square root. And since this 7 doesn't have any buddies, any extra 7s, we write the 7 on the inside. So you have 7 root 7. Alright, looking at 100. We know 100 divided by 4 gets us 25. We know 100 divided by 2 gets us 50. So there's multiple different ways we could approach this one. I like always dividing by 2 if it's an even number, so that's how I did it here. So I got my 100, and divided it by 2, so I got 2 and 50. 2 is a prime number, so I circle it. 50 is composite, because 50 divided by 2 gets us 25 and 2. So 25, well, 25 is not a prime number. It wouldn't be broken down anymore. That's why I don't put that red circle there. But 2 is a prime number, so I put a circle on it. 25 can be broken down to 5 times 5. Cross out the composite numbers. 2 times 5 times 5 times 2 gets us 100. So we need 2 of a kind. This 2 matches up with this 2, so we have a 2 on the outside. This 5 matches up with this 5, so we have a 5 on the outside. We have no numbers left on the inside. When we have no numbers left on the inside, the radical goes away. 2 numbers on the outside, we just multiply them together. 5 times 2, which gets us 10. So 6 is D, 10. Number 7, there's multiple ways you could do this. You know the square root of 36 is just 6. Now let me show you the longer way, just so you can see it. So I take my 36, since it's an even number I like dividing by 2. So 36 divided by 2 gets you 2 and 18. We know 2 is a prime number. 18 is composite. 18 divided by 2 gets us 9. So we have 9 and 2. Now 9 is composite, so we don't circle it. We circle the primes, which is that 2. And 9 divided by 3 is 3, which consists of 2 prime numbers there. 2 times 3 times 3 times 2 gets us 36. 2 on the outside, because these 2 put together make us a 2 on the outside. This 3 and this 3, we also put that on the outside. There's nothing left on the inside, so we delete it. 3 times 2 gets us 6, and that's how we get square root of 36 is 6. Look at number 8. We have the square root of 28. 28 is an even number, so I like dividing it by 2. 28 divided by 2 is 2 and 14. 14 divided by 2 gets us 7 and 2. 7 is a prime number, so we circle it. And 2 is a prime number, so we circle it. So we have 2, 7, and 2. This 2 matches up with this 2, so we put a 2 on the outside. This 7 doesn't have any buddies, doesn't have any matches, so we just leave it on the inside. 2 times 7, I'm sorry, 2 radical 7, that's why we get D, 2 radical 7. Let's look at number 9. We have the square root of 112. 112 is a nice, pretty even number. 112 divided by 2 gets us 56, so we have 2 and 56. 56 divided by 2 gets us 28 and 2. 28 is also divisible by 2, 14 and 2. 14 is divisible by 2, so we get 7 and 2. So we have 2, 2, 2, 2, and 7. All our composite numbers will cancel. We don't have to worry about those anymore. Now, we're going to simplify this radical. This 2 matches up with this 2, so we put a 2 on the outside. This 2 matches up with this 2 on the bottom, so we put another 2 on the outside. And this 7 doesn't have any match up with anything, so we put the 7 on the inside. 2 times 2 gets us 4, so we have 4 radical 7. That's our answer. So 9 is A. Let's try this one, 180. $180 divided by 2 gets us 90. 90 divided by 2 gets us 2 times 45. 45 is divisible by 5s. 9 times 5, but 5 is a prime number, so you circle it. 9 is a composite number, so you break that down to 3 and 3. So we circle all the prime numbers. We delete the composite. So you have 2 times 2 times 5 times 3 times 3. 2 times 2. So we put a 2 on the outside. 3 times 3 and 3. So we put a 3 on the outside. That 5 doesn't have any buddies. So you put it on the inside. 3 times 2 is 6. So you have 6 radical 5. So Tennessee. Alright, ladies and gents. That's all the problems I got for you. If you have any questions, please email me. I'll be happy to help you out. Or come next show, because I'll also be happy to help you out there. Alright, have yourself a good night.